good thing if we can sort this out.
That? Yep, he was waving. He sees you.
Okay, all right, we will soon be live. Okay, that's better? Okay, thank you. Welcome to the Science Group, and good morning, Chautauqua. Oh, that's even better. Hi, I'm Bob Spiritus. I coordinate this. We've got Bob Hopper in the back, our president, who's going to run the show eventually. And we're lucky to have with us today a great speaker. We have Mike is going to speak, Mike Humphrey, and we'll let our second leader speak. Mark Wensler will do the announcement, but we just wanted to tell you that we're here for the summer, same time, same station every week, and we hope you enjoy the talk.
Thanks, Bob. It's good to see you back. Welcome, everyone. I'm Mark Wensler. I direct the Climate Change Initiative here at Chautauqua, and it's always a pleasure to partner with the Chautauqua Science Group. I think you guys have put together such an amazing lecture series, and thank you for letting me be a part of that and working with you. I'm pleased to introduce this morning a fan favorite, third time, I think, speaking at Chautauqua, in recent years at least, but has a longer history of Chautauqua. Mike Humphrey was brought up on NASA and Mercury through Apollo programs, which served to fuel interest in science. He loves outreach and works hard to provide audiences with the most informative and entertaining event he can. He joined the Buffalo Astronomical Association in 2010 and was the editor of the newsletter from 2014 to 2019. In 2017, he was given an Achievement Award from the Buffalo Astronomical Association College of Fellows for his work in outreach and developing a partnership with NASA's Night Sky Network. Mike then served as vice president and was elected president in 2018, a position he currently holds. Additionally, he was appointed chairman of the Northeast Division of the Astronomical League and sits on the board of the Buffalo Audubon Society. He volunteers as a NASA partner eclipse ambassador, promoting public education for eclipses so that they can be viewed in a safe and an awe-inspiring manner. Mike is happy to be back at Chautauqua, as he and his family have spent multiple summers visiting here. He has a special connection to the institution, as his daughter participated in the summer intensive dance program and later returned as an instructor under Jean-Pierre Bonafou. Thank you. French is not a language I speak. I just want to also say welcome to Kathy, Mike's wife. Are you in the back here? Way in the back. And just, the first time I met Mike, we collaborated on a star party here at Chautauqua. That was about 3 years ago. Was anybody here at the star party we did? Yeah, so we got one. So it was a great event, and we were so happy to have Mike as a partner on that. And we're talking about doing it again next year. So stay tuned, 2026, for our next star party with Mike. Welcome.
Well, thank you, guys, and thank you for having me back. I'm always love coming here, sitting and talking with everybody. One of the things I like to do, I love to do things on astronomy, and a lot of times people come in, they do a lot of pictures and things like that, and I love doing that. But sometimes I like to do something related to astronomy that's just a little bit different, gives you more of an insight and more information about some of the things that we do. Thank you. Can everybody hear me now? Excellent. All right. One thing, I'm talking about saints of astronomy. Now, the reason I picked this topic, and you'll see a lot of topics that I do a lot of programs and people ask me questions. If I get enough questions, I'll do a talk on it. And this is something where I got a lot of questions, a lot of people were asking me about it. So one rule, I will be using religion, but I will specifically talking about the Vatican and Catholicism, so Catholic religion. There's a lot of things, and I started getting really into it, where I looked at all the religions. Unfortunately, we only have an hour. So I'm going to stick with just one right now, but if we want to do it, I have a whole bunch of things, but I think we need to spend some extra time. So this is one of the questions I used to get. In fact, I still get this one a lot. Can a person of faith be a good scientist? And when I'm done, I think we'll have the answer for that. The other thing, what is the relationship of the Vatican to science? Now, I get this one a lot, because when people see and they talk about the Vatican, they talk about science, religion, they come up with this: science, religion, nah. If Do you know why? A lot of reasons, but there is one specific reason, one thing that comes up, and here's the date. 1478. Put that in your books. What happened in 1478? The Spanish Inquisition. And you know what? Nobody expected that. Between 1478 and 1834, the Tribunal of the Holy Office of the Inquisition looked into people who were not following Scripture and all of these things. The one thing they looked at science, and I'm going to specifically deal with one particular point, is heresy. Now, this is one of the trials, and this gentleman we see right here in the middle is Galileo. Galileo was being tried for heresy. Heresy because their interpretation of the Bible meant that the earth was a geocentric model. And in a geocentric model, it means earth is at the center of the universe. Galileo and other people have proposed, but Galileo published that this is heliocentric. Heliocentric versus the church stance towards geocentric was heresy. He had 2 trials, and for whatever you may have heard, he was not tortured. Actually, he was treated very fairly, but he was still tried on it, and then he ended up having to stay in his house. So he was under house arrest. This was for heresy. And just as an aside, we know that the heliocentric model is correct. Galileo, when he proposed the heliocentric model, did make a mistake. In his heliocentric model, the sun was the center of the universe. In the heliocentric model, our sun is the center of our solar system, which is the true model. So even though the science says something, sometimes we go just a little bit further and we find out, oh, that's not correct. And then we just move into the next phase. Now, regarding science and faith, the Catechism, this is the 2nd edition in 1997, said all of this. Now, when I read this, I did come up with 2 things. Faith above reason, there can never be any discrepancy between faith and reason. And this last part, nor can truth contradict truth. Truth is interesting because we know that there is a truth out there. Something is absolutely true. We find out different things, and through things in the way we know it, we learn things. And sometimes we have to modify that. So there is something that's absolutely true. But as we learn to develop and to move forward in what we believe is true. Now, in this case, the Catholic, they teach that the Christian faith and science are complementary. So we work together as we explore the universe. I wanted to take a look at a couple other Catholic scientists, and these are gentlemen, Copernicus, we know about him, we talked about Galileo, and these are people who had strong religious beliefs, but created and had very strong contributions into the science narrative. Another, René Descartes, Jean-Baptiste, Gregor Mendel, we all remember him. Georges Lamartine proposed the Big Bang cosmological, and this was in the early 1900s. So we can see all of these things are coming through. But as I started to go through, I found 3 names that popped up. One of the names, and these are the people, Domingo, Blessed Herman Richaud, and Francisco Fadebruno. These are the names that popped up most in my research when I was looking for people, and especially people on this particular level, when it came to dealing with faith and astronomy. I'll talk about this person first, which is Domingo. Now, Domingo is interesting for a couple different reasons. He's the patron saint of astronomy. However, in my research, the only thing I can find that actually relate him to astronomy is the 2 dreams. One, that his godmother had a vision of stars on his head, and that his mother said she saw a moon on his forehead in a dream. That was it. He is the patron saint of lost causes. He's the beginning of the Dominican order, and he's the patron saint, and his feast day is the 8th. I wanted to jump to this guy really quick, though. This guy is fascinating. Now, he's from 1825, Blessed Francisco. He has a formula, and we'll talk about him at length. A couple of things that he had done when he went to school, he studied with, and I always have to look this one up because sometimes I'm not great with the French pronunciations too. But Leverrier. He worked with Leverrier, who created and looked at the calculations to show that there was a planet, and that planet was Neptune. And this is going back, and he said, okay, well, these calculations show that there's an anomaly. This anomaly is related to gravity. This gravity is caused by this. This says that there's a planet of this particular size, and eventually it led to the discovery of Neptune, which at the time was the last planet in our system. And right now it's the last planet again, depending on how you feel about Pluto. Dwarf planet, regular planet, Pluto doesn't care, just wants to be in the game. I do want to show you this, though, because this is kind of interesting. He came up with the De Bruno formula. Everybody see this? This is one of the iterations. Talking about the formula just a little bit, this formula allows you, if you know certain integers, and you're looking for another integer, you can plug them into this formula, and it'll give you that answer. Give you an example, and this is a modern example. Let's say that you're looking at acceleration, and it wasn't around his time, but I'm going to use something from our time, which is a rocket. And a rocket that has a varied set of parameters, and we want to find out some information. But we have a lot of changing parameters. Number one, you have gravity, because gravity is going to change the further away. Number two, the rocket will be going faster as it accelerates because it's weighing less. So you have the weight going down, you have gravity going lower, plus you have the weight of the rocket, and you want to find out. All you do is plug those into this formula, and there's ways of doing it, and it'll give you that answer. Now, he didn't know about rockets. We do. Works for cars, too. If anybody wants to try it out, I would suggest giving it I tried it, and to tell you the truth, after a certain point, it was just kind of like, okay, I'm done with this. He felt called to the priesthood, and we had the ceremony with John Paul, who said he was set out on the path to help poor, humble, helpless, and making a giant of faith and charity. In the science field, he was able to bring a consistent testimony of the believer. So while he was a very, very strong scientist, he's still a believer. This is something else, because occasionally I will hear people say, scientists are trying to prove that the belief and that God don't exist, and that's not true. That's a fallacy. Now, this gentleman was extremely, extremely prolific. He was born the son of Count Austin. He was disabled due to a paralytic disease from early childhood, born on July 18th, cleft palate, cerebral palsy, and possibly spina bifida. But he was extremely intelligent. Sound like anybody we know? Maybe Stephen Hawking? He entered the Benedictines when he was at 7. So what did he do as he grew up? He studied languages, Arabic, Greek, and Latin, and he was fluent. He was in the Abbot of Richelieu, and at 20, he entered their order. Now, mathematics, astronomy, Christianity, he was doing all of these things at the same time. And what was truly fascinating, and I'm just going to jump back, I just skipped ahead, is he came up, he's credited with being the creator of the astrolabe. Now, I don't know if everybody's seen an astrolabe. Now, he's credited with it because he wrote instructions for building one. It may have been built before, but he's the first person to put down on paper that this is what the astrolabe should look like. And this is an astrolabe. An astrolabe you use for celestial navigation. So if you're out on a boat, you want to know where you are, you can use the astrolabe. It'll show you what the stars are. You can find out where you are, and you can find out in a certain way what time it is, depending on the season. This is the guy who built that. One of the other things, now this is his invention. Now, we all know a sundial. Before the sundial, we had this. Now, what this did was it told the time, not based on a shadow, but based on the position of the sun over the horizon. The advantage is you can use this to find out what time it is, and unlike a sundial, which had to be calibrated to the north and south, this you could set anywhere, and you can do it at any time. The Horogam Victorium. If you look it up, we'll call it the pillar sundial, because that's what it was called, the pillar sundial. And if you have one in your yard, that's actually really cool. Despite his specific limitations, he was still very prolific. He worked very hard. He did a lot of things. He was just one of these people who didn't let his physical limitations define who he was. Now, I want to talk about the conflict between science and church. In 1889-70, declared that faith and reason are a mutual help to each other. The Catholic Encyclopedia of 1912, Conflict Between Science and the Church Are Not Real, and states that the belief in such conflicts are predicated on false assumptions, which we're starting to realize is actually true. Those are false assumptions. Scientists are not trying to prove that fate does not exist. Scientists are just trying to find answers to questions. The question is, how does this work? How does that work? What is the smallest thing? What is the largest thing? How big is the universe? We want those answers. It in no way does anything to any religion. It's just we want to know, why does that happen? And in this case, I don't want to read the whole thing here. Where did I want to read? That God has placed human heart desire above the truth and a word to know themselves. Again, they're saying that God is in a particular point, the science is in a particular point. We are doing the work that we need to do in astronomy because we like to do astronomy, but again, it's to find out things not in deference to religion, but in assistance to it. The papal astronomer, Brother Guy, I'm calling him Brother Guy because that's what we all call him, describes science as an act of worship and a way of getting intimate with the Creator. Now, the papal astronomer. When people hear the papal astronomer, get this question. And here's the answer. The Vatican has a telescope. Most certainly has in fact, they don't just have one telescope, they've had several. There's the mission, which is the Vatican Observatory is an institution established by the Holy See and astronomical research and public outreach to advance scientific and understanding of our universe. This is from the Vatican. And it's hard to hear the Vatican and science in the same time. And when I mention this, some people look at me like, Vatican, science? Those don't go together, do they? Well, they actually do. I'm talking about, and actually, the historical roots and tradition of the Observatory, one of astronomical institution, and it was one of the first in the world. I'm going to jump right in here. The Roman College is one of the first observatories that they put together. And then in 1827, the Observatory of the Capitol, and the Specula Vacana in 1789, and the Towers of Wind within the Vatican. Okay. The tradition of the observatory reached the climax in the mid-19th century with research at the Roman colleges and under Jesuit Father Succi. Now, I don't want to go, again, too much into this, because you guys can all read. And I figure you're all reading this slide. But just wanted to point out that the Jesuits and the Catholic tradition had a very, very strong intonations looking into astronomy, astronomical research, and different things because this is what they wanted to see. This is what they wanted to do. They wanted to know how the universe worked, not in deference to, but in addition to what they read into the scriptures. Now, the Holy See in 1990s established an observatory and declared to the world that the Catholic Church works hand in hand with science, but the telescope did not remain in Rome for long. The reason was because Rome was getting popular. As Rome was getting popular, what happens? People come in. When people come in, what do you get? Lights. And lights and lights. Became a problem because they were getting so many lights, and lights do have an effect on astronomical research. When we're doing deep sky, we really need it as dark as possible, so we try and go to areas where there's favorable skies. When you're talking to astronomers, you hear us talking a lot about favorable skies. In the 1930s, they had, and I'm going to show you a picture of this one. This was the last one that was in Italy. Then they decided that we're still getting too many lights. We got a problem. We need to go someplace where there's less lights. So, the University of Arizona. So, the Vatican has a telescope in Arizona. Pretty cool, right? That's what they did. They did a program with the University of Arizona. They worked with them for quite a while. And then through public grants and our private grants and endowments, the Vatican was able to get their own. It's called the VAT. The Vatican Advanced Technology Telescope. It's a 1.8 meter telescope, and I'm going to show you a picture of it in just a bit. But this was the Vatican's own. It's operated under the university, but now it's operated by the Vatican, and that's when we talk about Brother Guy. These are people who are operating this telescope to do research related to just different things. but all astronomical research. It's 1.8 meter, and I have 30 years. It's almost 34 years of operation now that this has been moving, doing different things. This is what it looks like. And just so people know, if you want to, you can visit. It's open to the public. You just need to let them know. But serious research is being done there. It's not like, I mean, if you go there, there's things to do, things to see, but it's a working observatory. So I highly recommend taking a ride if you can go there. This is the telescope itself. Now, having talked about the telescope, I do need to show you one slide, and there's two things wrong with it. The Vatican owns a telescope named Lucifer. Now, the first thing wrong with this, because this has appeared a lot of different places. First off, this picture of the telescope is not the one that the telescope that the Vatican has. Now we're going to talk about the second thing. We love acronyms. As an astronomer, I go out and we search for acronyms, and even in things, sometimes we move stuff around just so we can make it into an acronym, like VAT is an acronym. So, and I'm going to read this. The Large Binocular Telescope Near-Infrared Spectrographic Utility with Camera and Integrated Integral Field Unit for Extragalactic Research. There will be a test. Now, a lot of people felt that this was kind of clever because this object, this Lucifer, is actually not a telescope. In fact, Lucifer is an instrument that goes on to the Large Binocular Telescope. Now, the Large Binocular Telescope is a unit where there's actually two telescopes that are tied together, and it looks like a large binoculars. But this is one of those informations. It's an object that goes on. It goes on one of the objectives, so when they're doing research, they can use a specific machine to do that research and to find different things. And I think we still have, let me see if I have it on here. That's Lucifer. In 2012, because of all the things going on, the scientists up there decided, that's a clever name, but we're not going to do it anymore, so they changed it to Lucy. People still persist and say the Vatican has a telescope called Lucifer. Just so you know, and if somebody should mention that to you, because Lucifer, giver of life and everything, and they made up a whole bunch of stuff and none of it's accurate. Again, this is the VAT. And this is Brother Guy. We all call him Brother Guy. Now, Brother Guy was named as director by Pope Francis, and that was in 2015. This is part of that ceremony where Pope Francis named him as the director. Brother Guy is from Detroit. So the Vatican has a telescope in Arizona being run by a guy from Detroit. Huh. But wait a minute, the Pope's from Chicago? I don't know. This was his mandate. When Pope Francis named him, he walked up and he spoke with Pope Francis, and he says, "What is your mandate of what I'm doing?" This is what Pope Francis told Brother Guy he would be doing. Do good science. And I know this is accurate because he told me. This was him in a recent visit, actually here, to talk about Copernicus. And this is one of his books. Now, if you talk to a lot of amateurs and advanced amateurs in astronomy, and a lot of us, like I'm called amateur astronomer because I don't get paid for it. And that's the real difference. And the difference between us and the professionals is there's stuff that we as amateurs can do that the professionals can't. I can spend a year looking at one thing and becoming an expert in Orion or Betelgeuse. Professionals can't do that. They have to keep moving. The advantage is we all work together. So now there's such an influx of material coming in from the James Webb, from the Nancy Grace, and from all the other telescopes coming in. There's so much stuff coming in. They need our help to resolve and to go through some of that. But this is one of his books, which is Brother Guy, and most of the people I know have a copy of this book. A lot of them don't have a signed copy, but most of the people I know do have a copy. This is what it looks like inside. Okay, going back to the VAT, because now we've talked about the telescope. I mean, what are they doing with it? Okay, one of the things is MACHOs. Remember I said we like our acronyms. MACHOs, massively compact halo objects. We're going to talk about this in about a minute. Galactic evolution, Kuiper Belt object colors. Now, galactic evolution, because the size of the telescope, they're able to pull more material in, and we can see how things are growing, changing, and we can see as the inventory grows. Kuiper Belt object colors. Colors under spectrographic analysis will tell us a lot of different things. Is this object moving towards us? Is it moving away from us? What is it made out of? How fast is it going? Is it coming in slow, fast, slowing up, speeding down? A lot of different things we'll find out. Is it mostly carbon? Is it mostly hydrogen? Again, spectrographic analysis, which is why we look at the Kuiper Belt, we want to see some of those colors, because that's primordial universe out there. This one's kind of interesting because it's sort of the same thing, the galactic inventory, because we can now see more stuff. Because here's the secret. The bigger telescopes don't make things bigger. What they do is they pull more light in, and because they pull more light in, we can do different things with our eyepieces, and we can start actually pulling all that stuff together. And then scientific papers. Now, there's been a lot of scientific papers, but it's not just the papers that you look at. When you see the papers come through, we look at the citations. So I just grabbed a couple of the papers. This first one, periodic burst of coherent radio emissions from an ultra-cool dwarf, 144 citations. And what that means is that we look for a dwarf sun, and as it grows smaller, it'll start to throw out certain types of radiation. One of those radiations happens to be in the radio band. When we look at the radio band, by looking at that, you can tell what's going on within the star. And that will start sending out periodic bursts of radio, and as we pick it up, you can see that with the telescope because it's able to look into, and this is not visual, this is actually using analyzers so we can see those kinds of things. But this one had 144 citations, and these are several papers that were written. Here's another series of papers that were specifically written coming from information from the VAT. How much time we have? Oh, we got time. Okay, I want to talk about one thing. And I wanted to get back to this. This is on the machos. Because people ask me, what specifically have we seen from the VAT? Okay, machos. And we also have a thing called WIMPs, which is Weakly Interactive Galactic Objects. What happens is we know that we can't see black holes, you really can't see them, but you see the effect of them. Dark matter, you can't see dark matter, but we can see the effect. One of the things that happens with dark matter is if this is dark matter, as light is coming, it'll bend around it like that. If you are looking in the right spot, as that light bends around through galactic lensing, what will happen is you'll get a flash. If you're looking in the right space, you can see that flash. You look at something large, like, let's say a galaxy. Andromeda is the next closest galaxy. It's only 2.5 million light years away from us, so it's like a neighbor. If you look long enough, you'll see these flashes. One of the things they did at the VAT, and they wrote a paper on it, is by strong examination of the Andromeda, they were able to pick up some of these machos and be able to see these. And when you can find machos, you can find the WIMPs. These are, again, research, been doing those to try and find some of these things, and it's doing what we would call serious astronomy. I actually wrote a whole thing about it, but I didn't want to go into it. My explanation is actually what's in all of these. And I think on this picture, yeah, that white dot, that's the WIMP. I mean, that's the macho. So based on that, we look at science and religion and how they interact. It's more like this. So, thank you very much. And are there any questions?
Please come to the microphone and ask any of your questions so that we can record it.
while you're coming up, I'm going to put up two websites. One is the Vatican Observatory website. You can go in there and find out more information because they have a ton of stuff. The other one is my website for the Buffalo Astronomical Association. If you have a question, you can go to that website and go to info@buffaloastronomy.com. 9 times out of 10, I will be the person answering your question. Yes?
My question is, what was the background to the change in the philosophical thought in the Vatican that permitted them to go from being staunchly opposed to astronomy to actually embracing it? Because as you pointed out in one of the slides,
Yes.
they already have some astrolab in the 1700s.
Yes.
So there must have been a dialogue going on within the Vatican.
Well, we'd actually have to look deeper into the trial of Galileo, which, again, I would encourage you because it's fascinating. The second trial wasn't so much on heresy, but on some other things that he had done. Specifically, he sort of made fun of the Pope in the second trial regarding this heresy situation. The entire church was not against Galileo. There were people in the Jesuits who were actually for him and believed that the heliocentric model was the correct model. And as the time went on, that whole fervor began to grow, and people started to realize that scientific is starting to point out that this really does make more sense. So it's going back to interpretation of those specific passages of the Bible, was realize that not only did they have room, but it actually made sense to make that change. And so not to be so staunch. One of the things you're going to find, and I've been told about this, scientists, we take things, our theories, and if you ever see anybody who says this is absolutely the truth, this is the truth, nothing else, be careful of that person. Because most scientists will say this is the truth as we know it, or this is what we know now. Because I know things will change. When I was in high school, an atom was the smallest thing. And then you had suddenly a quarks. Now we're down to string theory. And, we're getting even smaller than that.
My second point is Copernicus was the one who actually, his dissertation proved the heliocentrism.
Right.
But in his paper, he cited at least a dozen times the Muslim astronomer Ulugh.
Yes.
Ulugh, who happened to also be the head of state in Samarkand of a kingdom there, and that ended really poorly for him. But he and his team identified over 1,000 stars in the firmament.
Right, yeah, and part of the reasons when I started, I said I'm only going to be dealing with the Roman Catholic, because when I look at some of the other religions and their contributions, this talk would be extremely long. And I know that you guys only have a certain amount of time. But if you look at the number of certain stars and you look in a catalog, a lot of them are Islamic or based in Arab. There's a lot of things, even when we look at something like astrology, you'll find some things related. And we're like cousins. Astronomy and astrology are like cousins. This is the best way to describe it. So that would be part of a later talk. And so I want to deal with one, because by the time I go through and all of the facets, but there's usually some aspects, and a lot of times when I see the aspects of people who are supporting certain theories, it's the Jesuits.
But yesterday afternoon there was a talk on Islam here, so
Yes.
that's why I mentioned Ulugh.
Yes, appreciate that.
Thank you for an interesting talk. I have an astronomically naive question for you. What is it about, you mentioned that the larger telescopes bring in more light. What was it about the Hubble and then Webb that allowed them to see so much further into the universe? What were the changes, the technological advances that allowed that?
Oh, that's actually that's actually an incredible question, because I actually do get that question a lot. Mainly because the Webb, the Nancy Grace, which will be lost in 2026, and Hubble. And actually, when you look at Spitzer and you look at some of the other ones, they're in space. Now, being in space, you get two advantages. Number one, you don't have an atmosphere that you have to contend with. Because you don't have the atmosphere, a lot of light bending doesn't interfere with what you're doing. The other thing is heat and gravitation. Again, because they're off planet, the heat causes heat waves, which distorts. And if you ever go out to an observatory, I can show you what heat wave distortion looks like. We can look at an object on the horizon, and you ever seen an object is shaking on the horizon? That's what that is. that interferes with what you're seeing when you're looking at something that's far away, because that light's going to be coming through all of that shaking. Hubble, because of where it's located, doesn't see that. And then when you look at James Webb, now James Webb is just about 1 million miles away from here in what's called a halo orbit at what's called a Lagrange zone, which is there's zones where if you put an object, the object will stay there, mainly because the force of gravity pulling it in and the force pulling it out equalize, and the object stays there. It's an extremely stable orbit, but it's 1 million miles away. Webb has a 5-year fuel. They have a 5-year mission, but enough fuel for 10 years. And they also designed a way to refuel it, because it's 1 million miles away, we just can't pull it back. Those telescopes and the ones that you see now, all of the space-based ones, have an extreme advantage. Also because we can run them in stable platforms, we can run them all year round, whereas we're limited to weather, when the weather changes, it's raining and things. Not many telescopes are out. Yes?
Isn't there still some controversy with regard to timing when we're talking about science versus religion? Some faiths, the Bible says God created heaven and earth, and some faiths imply that happened X thousands of years ago, when scientists know that happened X billions of years ago since the Big Bang.
Absolutely, yeah, and there'll probably always be controversy related to that. There are, and I don't want to say sects, but let's say divisions of people who believe that the science role is incorrect. I actually had a discussion with somebody who believed that the science of the Big Bang was incorrect, although I was showing him why it would be correct. And some of the things he said were moderately true, but there's a difference between faith and things that you know and things that you believe. And when I talk to people about things that you know or things that we can prove and things that you believe, and I can actually prove it, that's when you start coming into different zones. A lot of what you see in here, a lot of this was carried by certain aspects where they looked up and said, these are the things that we need to do, and they move forward, which is the easiest thing if everybody's on your side. Sometimes it's more difficult, but if you're able to look and say, this makes the most sense. I'm not saying anybody needs to give up your belief, but at the same time, you look at what the science record says too. And, belief is actually that. People need to believe something. And if you believe something, that's really important. And you don't need science. If you have science based on your belief, the problem is, what if they learn something else that shakes that science? What happens to your belief? Is there another question, or Bob?
Mike, I had a comment, something that you and I talked about last night. Folks may notice when you walk around our campus that we do have some really great dark sky resources here. I want to credit the Chautauqua Property Owners Association for leading an effort to make our outdoor lighting night sky compliant. And what that does, it makes us a friendly place to look at the night sky. It also has tremendous environmental benefits for wildlife that can be really impacted by light pollution. And, when we had our star party with Mike and his team a few years back, that was one of our initial efforts to raise awareness of the value of dark skies here at Chautauqua. Really pleased. I see Terry, you're here. I don't know if is Bill here? Bill, hey, have really helped lead that effort. And we had a great meeting yesterday. We're talking about kind of getting that job done in the year ahead and achieving one of the first dark sky compliant communities in this part of the country. So I just want to say that's a wonderful effort by you guys. And I think we're going to help celebrate that hopefully next year when we bring Mike and his team back for another dark sky party.
Yeah, we're kind of looking forward to it. Other Bob. Go ahead.
Hello there. Next week, we're going to have what may seem even more distant to our general topics. We're going to be talking about the science of professional sports. And I have found a man. He's the on-field advisor to the local baseball team, the Jamestown Tarp Skunks. but he's also been a coach for 18 years with the Detroit Tigers and the Philadelphia Phillies. And he's a doctor of psychology. He's going to talk to us about how is it that we now worry about baseballs being pitched 104 miles an hour, and what does it do to bats and hitting, and how come all the pitchers now have their elbows break, and how come we're now getting gambling into sponsoring sports, and how will science look at what is that going to do to our lives? A lot of us believe and care as much in sports as we do in science. So that's going to be, I think, a very interesting talk, and it's going to highlight one of, I think, the main features of science, that science deals with what we can observe and what we can measure. And as that changes, we can look at different things, understand things differently, and struggle with, is there truth and what is truth? And so we'll like to see you next week. And for us to keep doing this, in addition to needing people caring about science, what do you think the other thing is that we need? Money. Yeah. So there's a little basket out on the back, and we'd appreciate your gifts, and we look forward to seeing you next week. And we're happy to have Bob back with us this week. Happy to have Mark with us almost every week, and we're so happy to be part of the Chautauqua institution's efforts to keep the lake functioning as a proper, clean lake and keeping our skies as a valuable asset. And just think, if there was such a thing as global climate change, how hot it might be. And, oh, there is. We'll see you next week. Thank you.